Thanks, Daryl, and happy to be here. Um, I'd like to provide an overview kind of various trends that we're seeing. If we look back over the last 20 years, we've seen massive growth in fiber capacity per fiber, and that's through a combination of different things, right? DWDM technology, coherent technology, flex grid ROADMs, photonic integration. When we look to the future, some of these things we're running out of the ability to do the same thing we've always done in the past, and we need to look a little bit differently. But I think we still have a toolbox, and that's kind of what I'm going to talk about, is what is that toolbox, and particularly as it relates to coherent interfaces, what does that mean about priorities for development of next generation coherent interfaces. As we look historically through this evolution, going back to the early 2000s, deployments of DWDM networks were 10 gig NRZ on 50 gig channels, really not pushing the limits of that spectral efficiency very much. We were able to move up to higher baud rates at 25, 30 gigabaud. The introduction of coherent moving all the way up to 100 gig and then 200 gig, and still being able to achieve the kind of performance that could close a lot of links and really be usable in a lot of applications. As we move even further, the most recent systems, coherent solutions, we have a tremendous amount of flexibility, both on the transmission to adapt the characteristics of the transmission to really be optimized for the channel and fully utilize the spectrum. We also have the flex grid technology that allows us to adapt the network to be able to match the transmission. So we now are really efficiently utilizing the spectrum in fiber. And so as we look at a certain modulation format, you are roughly going to get the same capacity per fiber. As you increase baud rate, you're going to increase the capacity per wavelength, but you're not actually changing the capacity per fiber because you're using a wider spectrum. At 64 QAM, the reaches are at a point where that's pretty much where it makes sense to go from a usable reach in even some of the edge applications. We don't, it starts to be diminishing returns going beyond 64 QAM. And so we're kind of at this point where we have built out the basics of effectively utilizing the spectrum and kind of the easy improvements in increasing the amount of capacity per fiber. In addition to just utilizing the spectrum more efficiently, there's been a lot of talk recently about how we're approaching the Shannon limit, and that's because as well as very efficiently utilizing the spectrum, we've also added things like higher gain, soft decision FEC, and these shaping capabilities, so that we're really getting very close to, for a given amount of bandwidth, the amount of traffic that we can pass through that. So looking forward, the next generations are really, there are still improvements to be made, but it's going to be a bit more marginal in terms of the improvements. It's not going to be like when we went from 100 gig to 200 gig and we put double the amount of capacity through the same channel. So when we look toward what does that mean for how do we cost effectively scale the network? So it's not just about how much capacity there is in a fiber, it's really about scaling the network capacity. And so what does that toolbox look like? Well, increasing baud rates is still, it's always been kind of the go-to in the industry, and that is still a key driver. And so we will continue to work toward higher baud rates, but that's really just about the cost of the solution. So as you can cost effectively drive to higher baud rates, you can reduce the cost per bit of the transmission. You can increase the capacity in the network by expanding to both C and L band, and basically double or nearly double the capacity of the network. that doesn't come for free, right? You're doubling the number of transceivers, you're increasing the cost of the line system, but you're efficiently utilizing your deployed fiber, and so in a lot of cases that makes sense. If you're deploying a new network, you can deploy multiple fibers or multiple cores and basically take a parallel approach. Again, this still costs you additional transceivers to do multiple to light up multiple fibers or cores, but it gives you a path to grow the capacity of the network. And then another way you can do this is by more regeneration. So your ability, the capacity you can transmit is related to the signal to noise that you can support on the line. And so if you make those links shorter and do more regeneration, then you can have higher capacity across each one of those steps. But again, that drives the need for more ports. So if you look at this overall, there's a lot of other implications in the network. So implications on ROADM technology and everything, but we make transceivers, and so from a coherent perspective, what this means is we need to move toward faster speeds, and we need to drive the efficiency and the ability to deploy more of these ports in a way that is both cost and power efficient. And so moving toward the next generation, we made a tremendous amount of improvements. If you look back over the 20 years, even going back over 10 or 11 years of the coherent phase of that evolution, tremendous improvements in both silicon and indium phosphide on the integration capabilities. And we now have highly integrated devices that are able to achieve really, really exceptional performance. And that allows us to make improvements in power, improvements in reliability. We are moving toward package level improvements. Acacia's been using silicon for quite a while, and we're now moving toward package level improvements because as we look toward higher speeds, we see that the limitation in performance can often come from the interfaces in the packaging. And so by developing highly integrated silicon devices, we have benefits in both the manufacturability, and we're able to utilize some of the common electronics manufacturing, but we also get the kind of performance that you can only achieve by making these interfaces really short and co-packaging. And so we think that this will be an important step in terms of driving the cost of the solutions and the power down to a point where we will be able to deploy more of these to scale the network. We've talked for a long time about coherent and the evolution towards shorter and shorter reaches. Started in long haul, moved toward metro, now moving much more toward the edge. We see we've introduced products that are targeting coherent in access applications. I think a lot of people see ultimately coherent moving into the data center. Probably still a little ways, generation or two off, but gradually moving shorter and shorter interfaces. These shorter interfaces tend to be higher volume interfaces, and so as we move toward shorter, higher volume interfaces, we need again to focus on power efficiency. It tends to drive a much stronger requirement for pluggable solutions, and it drives the need for standardization, which has been a hot topic recently. Just for perspective, I thought it was interesting to look over the last 5 years. If you look at the distribution of coherent ports, and this is data coming from Signal AI. If you look 5 years ago, roughly 60-40 split between deployments of coherent ports in long haul relative to edge and metro. And you can kind of see metro ends up being sort of the transition phase there, where in 2016, the Metro solutions were really a derivative of what was deployed in the long haul, and really was a long haul solution adapted for Metro. Now you look in 2020 and it's 60-40 in the other direction, where Edge and Metro is more higher volume than the long haul, and you see now Metro solutions that are being developed that are leveraging the 400ZR technology, and so there's a pivot that has taken place where the Metro solutions are being adapted from the growing Edge market and being aligned. And sort of big picture here, I think what the takeaway is that we have to think a little bit differently in terms of these are all they're always going to be specific solutions for the different markets, but where the driving force was long haul, and then we tried to tailor solutions for Edge and Metro from those long haul solutions. It's migrating more toward the long haul needs to be more informed by the Edge and Metro solutions. So just a little bit of a different way of thinking about things. I mentioned coherent standardization. This latest generation of, driven by 400ZR, or at least initiated by 400ZR, has really widened the level of standardization. So we now see 100 gig was initially driven by Open ROADM and ITU, and then adopted by a number of other standards bodies. And then 400 gig ZR started another generation of standardization that really widened the number of applications that were targeting standardized solutions. So 400ZR itself is really driven toward kind of hyperscale edge applications, but then we also have Open ROADM, which is targeted more toward carrier applications, Cable Labs, which was targeted more toward edge access in the cable networks. And then we have MSAs like the OpenZR Plus MSA, which is kind of taking a combination of the features of 400ZR and the performance of Open ROADM and putting that together as a unique solution. So we've built out this range of different solutions, all based on standardization, standardized interfaces and interoperable interfaces. And so it's expected that this is going to increase the adoption of interoperable standardized coherent interfaces, and also pluggable interfaces that are derivative of these interoperable. So there's always a choice of whether you want the interoperable or whether you want a plug that is maybe still bookended, but still giving you the benefits of pay as you grow and all of the reasons why people have been deploying pluggable coherent solutions for several years now. As we look toward next generation standardization, we've seen the early standardization went from 30 gigabaud to 60 to 64, depending on the specific implementation. We need to look at the next generation standards and see where is that going to go, because since these standardized interfaces are driving broad industry investment and really driving the applications where we see the significant volume growth, it's important to be informed where these standards are heading so that we can inform all of the rest of the architectural decisions. We think that the most straightforward way to do this, looking to the future, is to move toward, again, doubling the baud rate, because what this would allow us to do is to have solutions that can have similar types of reaches as what we've done in the current generation. So you could move from a 400ZR to an 800ZR, maybe some additional enhancements, but it's probably going to be necessary to go to that higher baud rate to have the kind of performance to meet the same applications as 400ZR. We also think when you look toward this next generation, where 400ZR opened a round of standardization that tended to focus on ZR applications, 80, 100 kilometers and above, where it moved into some of the carrier applications. We also see an opportunity here at 800 gig, where Coherent probably can make sense in shorter reach applications that are maybe a slightly more power optimized, cost optimized solution compared to ZR. So maybe it's an LR or an ER type interface at 800 gig that starts to be of interest as well. So transition from 400 to 800, you may see a different focus as opposed to 400 ZR and ZR plus. Maybe it's a ZR and below. We also see that in the next generation, it's going to be there's an opportunity. If you double the baud rate, now you have an opportunity for 400 gig performance using QPSK, which really gives you, the kind of reaches that you can cover any lengths, even going out to long haul type performance. And so, we think these are the drivers that are going to influence the next generation of coherent investment, and likely where the standardization process can lead us. And it is important. It's important to be informed by where these standardization efforts are going as we look toward our next generation across a range of different applications. So, I talked about the toolbox that we have available in order to address scaling the network from a coherent perspective. That largely means driving more cost-effective ports, and both in terms of going to higher speeds and doing that in a more cost-effective way. I think the trends toward disaggregation and standardization, those are going to continue. There's been, we expect increasing adoption with each generation as more work is done. The industry's been putting a lot of work into addressing the control plane. Domenico talked earlier about what needs to be done in order to address the control plane requirements and everything. And I think the industry's working through those issues and has made a lot of progress. And I think with each generation that will get better. Integration and packaging, I think, are key, not only for size and power and cost, but also for performance as we go to higher speeds. I think it becomes critical. And I think it's critical that we, as we look toward the high performance solutions, we now need to kind of look at how those need to be aligned with the broader investment that's going on in the high volume applications. Those high performance solutions will still be specific implementations. It's not that you'll just use the lower performance solution, but lower cost solution, but you'll take the investment and you'll leverage that where you might be able to utilize investments in drivers or TIAs or IP in the DSP technology. So I think the commonality between those devices will benefit the high performance implementations. Thank you.
Thank you, Tom. I can't resist. I have one question for you. I worry constantly about interoperability with respect to Coherent. I don't know what the current situation is, so can you perhaps give a brief review of where we are with respect to interoperability and what the future looks like with regard to that? Because getting to LR, you're going to need interoperability. I don't see how that's possible without.
Yeah, definitely. And I think, we've been through, a few years of interoperability work that I think the industry's done that is looking like it was really successful. I think we kicked off the OIF project in the Q4 of 2016, right? So we were 4 years from the start of that effort, and I think some of that process was more difficult than we expected, but some of it also went smoother than we expected. And I think we've been able to define a range of different interfaces. Interoperability has been verified. We've announced interoperability test result verification with Inphi and with NEL, and I think it's the protocols interop. We know that the deployments are being worked through, and I think we see that the performance is going to be good enough to address the target applications. So I think overall the work's not done. There's I think in terms of deployments, there's still work to be done, but the network operators are working through that now, and I think it's really promising. I think this generation of interoperable coherent solution will be widely deployed, and I think it's not something that is going to change as we look toward future generations. I think it's going to continue, and certainly I think we've shown some of the more difficult aspects of this generation of interoperability has to do with the fact that we're targeting DWDM applications. In terms of interoperable coherent protocols to address something like an LR type solution, I think the industry and the standards bodies are pretty confident at this point in the ability to define coherent. It's really a question of whether coherent's the right solution, but I think defining interop on coherent is something we know how to do.
Very good, thank you. We have a couple of questions from the participants. One, is 1.6 terabit under consideration for the next generation ZR or even LR applications?
So I think in IEEE, I think it isn't decided yet. I think the IEEE has been discussing just higher data rates beyond 400 gig, and so that's early in the discussion. I think there will be a range of different. There will be 800 gig solutions defined. I think there will also be 1.6T solutions defined, and I think both are being looked at for different reaches and different applications. In some cases, an 800 gig per wavelength solution might be part of a 1.6T interface, and so I think it's a little bit early to decide what the interface rate is, but I think combinations of 800 gig and ultimately I'm sure we'll get to a 1.6T per wavelength, but I think in the more near term, I think we're probably looking at 800 gig per wavelength, but that could also support a 1.6T interface.
Okay, and we have a question. I think Domenico has a question.
Yes, I have a question, Eitan, do the presentation. Thanks. Hey. But it's also for you, Dali. I think definitely the trend is doubling the baud rate or growing the baud rate is a path forward. But there is a fundamental problem is how do we interconnect the host card to these devices? Because from the server's perspective, probably we don't have now a straight roadmap as it was in the past. Optics was following the servers. Now it seems that because of this technology and the announcement, the servers are starting to have a shorter brief with respect to the WAN interface. Did you give any thought? Do you have an idea how we can cope with this problem? That's also for you, Dali. I think both company as a key supplier and leader in the market. So you should look at how you deliver an end-to-end solution.
Yeah, I mean, I think we tend to focus sometimes too much on just the sort of the optical interface, but the whole ecosystem behind it needs to be there, and finding the right timing to take these steps on both sides of the interface. I think is critical. I think there is still a lot of work to be done. I don't know that I have a specific answer to the question.
Yeah, I agree. This is going to come in time as we evolve. We have one more question, if you will, Tom. Can you or could you do single transceiver to cover C and L bands would there be a significant cost or performance penalty?
I don't think it would be impossible. I think there would be a cost implication today. Just, you know, the supply base isn't built out, and I don't know that the solutions. I'm not aware of any solutions that would cover that today. L-band is still, while it's becoming more common, it's still much lower volume than C-band, and so everything related to L-band always is a question of it's technically feasible, but it doesn't make commercial sense. And I think we're still a ways away from the L-band deployments being large enough where it would be justified to make every part a C plus L-band. I think the cost implication of that in the near term wouldn't be attractive, but doesn't mean that it couldn't be, somewhere on that roadmap. It might make sense.
Okay, thank you very much.